Thank you everyone for coming this day. It's a very important day for Google. Today we'll announce Chubby log service to you. So let's start without any further delay. So, Chubby design decisions. Chubby is a log service for distributed systems. It will read and write small files. File accesses will be controlled by sessions, and files will be locally cacheable. But Chubby will manage those local caches, so that's an important thing. Also, our logs will be coarse-grained, so logs durations will be hours to days, and we will provide strict consistency. So, let's move on with architecture. Here we have 5 servers in a Chubby cell and 2 clients who wants to access to our files. So, here we go. We performed an election and we elected a master and replicas. So, client applications by using DNS servers sends RPC requests to master and accesses to files on replicas. An important information, client applications may only communicate with master. They don't know anything about replicas and their addresses also. So, let's move on with log system. It's a very important aspect for Chubby. So we have a client application, again 5 servers with a master, and we have a file on a replica. The client application wants to access this. So client sends a log request to master, and master logs the file on the replica. Then client may perform any write and read operations on this logged file. After the log lease is expired, then the log is removed, and other clients, here the client comes, other clients may use the file, log it, read it, and write it. So let's move on with sessions. Sessions are required to manage relations between client and the Chubby cell. So let's look at the session operations. Client sends a message to the master, a session request. Master replies to this session request, as you can see. So now client may send, write or read requests to master. But from now on, client also should send a periodic heartbeat message named keep alive to keep session up. As you can see, it sends a read and write request, again a keep alive message. Now it does not send a keep alive message, and write request denied. So let's move on with caching. Caching is reduced to read traffic. Some metadata and files may be stored in the cache, local cache. So let's move on. Client sends a read write request to master, master replies. Then master sends the file or the metadata to the cache. From now on, client uses cache for this file or metadata. At some time, another client updates the file or deletes it. So master sends an invalidation to this local cache. And from now on, client uses master to access the content. So I want to repeat again. Chubby is a manager for all local caches. That's a very important aspect of Chubby. So let's move on with following changes. That's also very important. We want clients to know if there's a change occur at files, at metadata, or at nodes. So we have different events that are triggered by master. Let's see our events. Child node added, child node deleted, file modified, log conflicts, log occurred, master failed, child node modified. We have 7 different events, and these events are one-time events. That's also very important. So you can't follow events by sending a single request to master. So there won't be unnecessary messaging between the client and the server also. So, do you have any questions about Chubby? Then, thank you for coming, thank you for listening.
Thank you all for attending this evening. Today, it is an important day at Yahoo headquarters. We are going to announce Zookeeper. While developing Zookeeper, we had to decide on some design decisions, which are: we don't enforce usage of blocking systems such as locks. We encourage clients to implement their own various operations. By the coordination kernel we provided, we only allow full writes and full reads of small files. We assume reads dominate write operations. File accesses are controlled with sessions. files are cacheable, and the most important thing is we relax our consistency model to improve on performance. And we call it Zookeeper because managing distributed logs is like managing a zoo. Here you can see our architecture composed of 5 servers, and one of them is elected as leader. Clients can connect to any of these servers and can read from any of them, but writes have to go through the leader. And to follow changes, we implemented a watch system. What are watch? Watches are one-time events, and if you are notified by a watch, then you have to register again, so you won't be notified twice for the same watch. And we have 4 watch types like these. To implement a log, first you have to have a parent file which will serve as a log, and clients create sequential files under this parent file. Sequential file creation means there is a monotonically increasing counter which is appended for each file names. So this is the picture if 3 clients queue up for the same log. So in our animations you see how logs works. We have owner of file 1 and owner of file 2. So owner of file 2 watches the deleted watch of file 1, and file 1 has access to critical section because it's the lowest file on the directory. So file 1 operates on the critical section and then deletes its file, and watch response is sent by Zookeeper service to owner of file 2, which can now operate on the critical section. And we have various other primitives like configuration management, which enables clients to implement a changeable runtime changeable configuration for the distributed system. We have group membership, which allows processes to form groups in a distributed environment. And we have double barrier, which enables us to synchronize start and end points of a calculation. We have many similarities with Chubby. For example, both can be used as a distributed log service. They read and write small files, and we only allow full read and full writes. We both provide Unix-like file system, and we both provide mechanism to follow changes. In Chubby it's called events, in Zookeeper it's called watch. We both contain session system for file accesses, and clients have to go over leader, master for write operations in both of us. And differences are Chubby is a distributed log system only, where Zookeeper can be used to implement distributed log system, but it's much more than that, more generic. And in Chubby, clients must communicate with master for read and write operations. In Zookeeper, they only have to communicate the leader with write operations. Chubby does not offer any primitive operations besides locking, and Zookeeper offers many primitive operations which can be implemented by the clients. Chubby provides 7 events to follow changes. Zookeeper provides only 4. And Chubby manages clients' caches directly. In Zookeeper, clients manage their own caches. Chubby's implementation causes slow or faulty processes to hang up the fast processes. And thank you for listening.
Thank you for leaving the stage. I need to make a formal announcement, sorry for interrupting your presentation. As you all know, we introduced Chubby previously, and after that, Yahoo announced Zookeeper, which has its own value, of course. It offers many primitive operations, but I want to declare that Chubby has still its value. If you need strict consistency, and if your clients have similar speeds, then Chubby is still the solution. Thank you for coming, thank you for listening. Goodbye.